All right. As a human, if you work your jaw, you can feel the muscles in your cheeks and the muscles that to attach to your jaw. And if you're chewing your food, it doesn't fall out of your mouth because you have cheeks. And inside, if we look at a skull of a human, we can see that inside of the cheeks, where the teeth actually are placed, is inset. The teeth aren't right on the edge of your face. Your teeth are inside, making room for the muscles in the cheeks. They control your jaw, and that also keep your food inside so you can move it around with your tongue and chew your food. Most dinosaurs don't have this. Most archosaurs don't have this. Crocodiles, birds, they don't chew their food. Mammals, most of us chew our food, so we take this for granted. But I would like to point out to you that chewing food is actually one of the most interesting derivations of the ornithischian dinosaurs, including the ceratopsians. If we look at this juvenile Utahoceratops, I can point to where the teeth are inset and the jaw is a lot wider than the tooth, allowing muscle attachments to wrap around, but also allowing a place where this animal would have cheeks to allow the food to stay inside the mouth, while a battery of teeth that grind the food can chew it up before the animal swallows it. And if we look higher at the adult Utahoceratops, we can see the same thing, where the teeth are set inside the face, and there's a lot more skull and jaw, just like on a mammal, that allows the presence of cheeks, so these animals could actually chew their food. Because we chew our food, maybe we think that's not so impressive, but a lot of dinosaurs could not. Now, we can also talk about the difference between horns and antlers. If you are familiar with the Mountain West presence of antlers on animals, a common sight is to find antlers that have fallen off in the woods and been stored in somebody's house. Antlers are made of bone. And in some animals, those antlers grow and the entire antler falls off. But horn is different. Horn has a core of bone on the inside and then a coating of thick protein that we call keratin on the outside. Now this horn is from a sheep, which is a mammal just like us. But you can see the keratin coating of protein that was on the outside of the bone. This sheep would not drop its horns and lose them. The keratin would always be there, like your fingernails are growing, like your toenails are growing. And if we consider our dinosaurs, there are a lot of places that they also would have had keratin covering bony protrusions. So we call those horns not antlers. So here on the juvenile Utahoceratops, the brow horns, the nose horn, the cheek horns, little horns that are present around the frill, all of these would be covered in a thick protein coating just like this. And even the front of the face, the predentary bone, which is shared by all ornithischian dinosaurs, ceratopsians have this rostral bone. In the case of these derived ceratopsians, we would expect a thick protein coating of keratin on both parts of this beak. And what we've learned recently is that the keratin produced by diapsids, that's archosaurs, crocodiles, dinosaurs, birds, includes different ingredients than the keratin on mammals. That's us, humans, sheep, our fingernails, this sheep's horn. And the keratin found on dinosaurs would have been, like the other members of their living relatives, capable of making different structures with different properties. And that's it.